Alright, in this video we are going to be simplifying radicals when we are multiplying and dividing. So this is now taking that last video just a step further where we just had one single radical and we were trying to simplify that. Here we've got multiple radicals possibly and we're either multiplying or dividing, and we're going to see what we can do to simplify those. So in this first example we've got the square root of 2 times the square root of 14. And this, we really have two different options, and I'll split up these two options. Our first one is just to multiply the two together. All right, we could multiply square root of 2 times the square root of 14, to get the square root of 28. All right, once we have the square root of 28, I can say, well, that's really just the square root of 4 times the square root of 7, which gives me 2 times the square root of 7. When we have smaller numbers, this is a great option. It's pretty easy to run through when you can first take a look at square root of 2 times square root of 14 and realize, well, we can't simplify either of those on their own. Let's try and multiply them together and see if we can go from there. Our second option, when we start with square root of 2 times the square root of 14, is we can first just start by identifying, well, 2 is a factor of 14. So at this point, I can rewrite this as the square root of 2 times the square root of 2 times square root of 7. I'm splitting up this square root of 14 into square root of 2 times square root of 7. The reason for that being, when I multiply the square root of 2 times the square root of 2, sure, I could write that as the square root of 4 times the square root of 7. Well, square root of 4 is just 2, so I get 2 square root of 7. So what we notice here is whenever we multiply the same radical by itself, so for example, square root of 3 times square root of 3, we're just going to get 3. We're just going to get that number. Here we had square root of 2 times square root of 2, just giving us 2. All right, let's move it along to this next one. We've got square root of 7 times the square root of 35. So in this case, if we tried that first method and we multiplied them together, we said square root of 7 times 35. Again, we can combine those two because it's multiplication. Multiplication and division, we could combine. Addition and subtraction, we cannot. So 7 times 35 is going to give us 245. At this point, that number is just too large. It's not really easy for us to work with and try to find, what's going to be a perfect square factor of this. So I would not recommend going with that first method. Instead, I would take a look and see, well, square root of 7 times square root of 35, I immediately notice that 7 is a factor of 35. So I can rewrite square root of 35 as the square root of 7 times the square root of 5. Then, because I have the square root of 7 times the square root of 7, that's just 7 root 5. All right, so that problem is made much simpler just by identifying 7 is a factor of 35. All right, for this next problem, we've got 2 root 6 times 4 square root of 3. Whenever you are multiplying two terms with radicals, we are going to multiply the integer coefficients together. So those coefficients, the number that are outside of the radical, we'll multiply those together and we get 8. And then we can multiply the square root of 6 times the square root of 3, getting us square root of 18. All right, square root of 18, we think about, okay, what numbers go into that? That might be a perfect square. And we can see 9 is one of them. So we've got 8 times the square root of 9 times the square root of 2. That's 8 times 3 root 2, which gives us 24 square root of 2. So that is our final answer there. All right, what about division now? We've got 6 divided by the square root of 2. So whenever we see a radical in the denominator, our first goal is to get that out. All right, get that out of there. We don't want a radical in the denominator. Well, how can we get rid of it? If we think back, we know that if we were to multiply square root of 2 by the square root of 2, that would just give us 2. All right, we would wind up just getting 2 in our denominator because you multiply a radical by itself, boom, you're just getting an integer of whatever number is underneath that radical. However, we can't just willy-nilly multiply the denominator by the square root of 2. Imagine if you were trying to get a common denominator, right? If you were doing addition and you had 3/4, you can't just multiply that by 2 in the denominator and say, well, now it's 3/8, right? What do we have to do? We have to multiply the numerator by that same exact number. So instead, 3/4, we could multiply by 2/2 to get 6/8. Here, we will multiply by the square root of 2 over the square root of 2. That gives us 6 times the square root of 2 divided by 2. Well, 6 divided by 2 is just 3, so we get 3 square root of 2 as our final answer there. Let's try a couple more. For this one, we have the square root of 5 over the square root of 10. So what we might notice is we can actually combine these into one big square root and make it the square root of 5 over 10. Well, square root of 5 over 10 is just the square root of 1 over 2, which then we could split up as the square root of 1 over the square root of 2. Well, square root of 1 we know is just 1. If you wanted to jump straight from this step to this step, you could definitely do that. You're dividing both the numerator and denominator by the square root of 5. All right, so you could definitely jump right there. I'm just showing you how else we could get there. All right, so we get to square root of 1 over square root of 2, which is just 1 over root 2. At this point, well, I want to get that square root of 2 out of the denominator, so I'm multiplying the numerator and denominator by the square root of 2. In the numerator, I get 1 times the square root of 2, which, of course, we could just write as the square root of 2. We don't need that 1 out in front. And then in the denominator, we are doing root 2 times root 2, which is just 2. So our final answer is the square root of 2 over 2. All right, for our last example, and probably the most challenging one so far, we have 3 times the square root of 12 over the square root of 18. Again, we could turn this into 3 times the square root of 12 over 18. And we know that we could simplify that. That's 2/3. So I simplify that as 3 times the square root of 2 over 3. And that's 3 root 2 over root 3. Notice how when I went from this first one to this second one, the 3 does not change. Okay, the 3 is staying the same because it's not in the radical. As we are simplifying radicals, or if I want to simplify this radical 12 over radical 18, the coefficients on the outside are unaffected. Okay, if I had a 9 or something on the outside and I wanted to simplify 3 over 9, good, you simplify these as a pair. Okay, you simplify the radicals as a pair and you simplify those numbers that aren't under the radicals as a pair. All right, at this point, we are just going to multiply the numerator and denominator by the square root of 3. So now we have 3 times the square root of 2 times the square root of 3 over, well, square root of 3 times square root of 3 is 3. Square root of 2 times square root of 3 is just radical 6. And at this point, we notice, well, I've got 3 times radical 6 over 3. I can simplify 3 over 3 to just be 1. Boom. And I am left with just radical 6 as my final answer. Hope this helps you guys out. Best of luck as you get ready.